This is part 2 of my DIY Christmas light installation. As a quick recap, I have two controllers. These are made by Zengi. They're a Bluetooth/Wi-Fi, and I have two power supplies. I'm doubled up because I have one run that runs this way and another run that runs this way on my house. So far, these little controllers, which are pretty expensive, have worked okay. However, they have a few problems. The first problem is they do not let me control the white channel individually. They also sometimes have a random flash to the whole string of LEDs, and for some reason they are limiting the amount of power to the LEDs. For some reason they're trying to keep a constant power, so I can't get full brightness out of the LEDs, and I can't get the full color mix that I want to do. So I'm thinking of putting in here a ESP32 running WLED, and I might put a little Ethernet switch here. I'm using the ESP32 hat made by Wasatch Pixels. It's a nice little circuit board that allows easy connection and has the appropriate 3.3 to 5 volt buffer. While I'm doing this, I'll try to clean up my mess here. Up here, it looks okay. So I have the red turned on to full intensity. That's 155 LEDs, and I'm drawing 2.38 amps. So that's roughly 28 watts. No, I just didn't do that in my head. I ran the numbers just a second ago. I divide that by 155, and that gives me this number on that UFO channel of roughly 0.17 watts. I have the RGB channels set to full intensity, and we can see that the current has not changed for driving all three LEDs at the same time. Mystery solved. In my first video, I discussed this little controller that came with the ETOP kit, and this is made by a company called Zengi, Z-E-N-G-G-E, and the Android app is called Surp Life for Surprise Life. It actually does quite a few things quite well, and is $20, and it also has a cloud interface as well. So pretty amazing, but it has a couple of problems. One of the problems is it does not allow control individually of the white LED channel. For example, if I come in here and I want to select the whole string being one color, all I can control is the RGB. I can't add white. Now, if I come down here to white, I can control the whole string. So maybe a better way to illustrate that is I can come into this scribble mode, and here I have red and white selected, and here's my pattern. And if I decide I want white here, this is the mixture of RGB. I cannot select the pure white LED. So that's a little bit of a problem. The next issue was that the LEDs did not seem to be drawing as much power as they should. The LED is rated for, I think it was 0.9 watts, and the most I ever saw these go up to was 0.4 watts. I was initially thinking maybe it was a problem with my power supply not measuring accurately. I started looking at the signals with my oscilloscope and saw that when I think there should have been all ones going to the LEDs, it didn't look that way. So here's the investigation. What I've done is I've got one LED puck hooked up to the Zengi controller, and I have another LED puck hooked up to this little microcontroller. Yeah, this is a TI Tiva. It's an M4 ARM microcontroller. It's my favorite little microcontroller that I use. And I've written some custom code in here that will send a FF to each color individually and together. And I know that it's sending out the proper data, and we'll make some measurements. I have the LEDs covered here with a diffuser and a white piece of paper so they're not quite so blinding. On my power supply, I've got this channel is hooked up to the Zenji, and this channel is hooked up to the TI Tiva. So we'll turn both these on and we'll start controlling these. So I have both of these programmed to red, and I'm using the app here, and I'm using the slider mode in the colorful setting. So I'll go to slider, and I've got the slider set all the way to full intensity for the red, and the G and B are off. We can see here, hopefully you can read this, but this is 0.17 watts. The custom programmed microcontroller over here is sending out all red, FF, and it is 0.31 watts. So roughly twice the amount of power is being pulled from this LED pack. Now I doubt that we'll be able to see here, but the right LED pack here is much brighter, and it should be because it's pulling full amount of power. So let's do the next little test that was a mystery, is when I tried to turn on two colors at the same time. So I'm going to step through here, and okay, so this is red and green full intensity, and we were initially about 0.3 watts, and we are now about 0.53 watts, almost double. So that's exactly what I would think if I were to turn on both colors, that my power would double. Red and green. Okay, and so we can see that we have roughly the same hue going here. I'm still 0.17 watts. And so this thing is trying to manage the power to always stay at the same, regardless of how many LEDs I turn on. And here again, I can see, again, the camera's not going to pick it up, the LED on the right is much, much brighter. So this kind of explains some of the things I've been seeing out on my house, is that the colors are not as bright as I was thinking they should be, and I can't get a full mix because this thing is artificially always limiting the data stream going out to the LED packs. Pretty crazy. We're now white, we've got everything turned on full, and I'm going to cycle through here. This is white created by RGB, this is white created by RGB, and we can see the difference here again, that the one on the right is much, much brighter. I'm pulling 0.74 watts. Here I'm still only drawing 0.17 watts. When I switch over to WLED, I've done some initial measurements there, and it acts like this. And so the string is going to look much better, much brighter. Now, if I go to RGB plus white, I can see that I'm pulling 0.95 watts, and that is near what the manufacturer told me the system should draw. And made all the measurements. We'll stick this in here, and we can see here's the UFO, and regardless of red, green, blue, red plus green plus blue, green plus blue, RGB,
The amount of power that is supplied to the LED pack is the same. It only changes when I add the white, and we're roughly 0.4 watts, where I can take the TIVA, that's the ARM M4 with the custom programming, and I can get up fully to the fully rated power, and the colors look much better. And I have already hooked up a WLED controller, and I am getting similar results, just a touch less power, which is interesting, to my custom solution. The WLED does do one thing that seems a little odd, in that when I say give me RGB, it will also turn on the white channel, and I only wanted just the RGB. I'm moving on. Here we are. I'm using the WLED on an ESP32. This little board on top, this little hat, I purchased from Wasatch Pixels, and it has a voltage translator from the 3.3 volts to 5 volts, and has some nice connectors. It's a good little solution. I also bought the ESP32 module from them. They had it already pre-loaded. I am using the version that has the built-in Ethernet connection rather than the USB. So the first thing that I encountered is that this thing does not boot some of the time. So what I'm going to show here is we can see this little the Ethernet activity LEDs. I have my Regal DP832 power supply here. This channel is powering the LEDs. This channel is powering module here, the ESP32. I'm going to turn that off. We'll turn it back on, and we're going to watch for the activity LEDs. Look at that, they never come on. This never booted. Did quite a lot of experimenting, and this is what's going on. The ESP32 module is very sensitive to the power supply turn on time or rise time, and if it is not fast enough, the module will fail to boot. And it just so happens that the 5-volt output of this bench supply has a controlled kind of a slow ramp, and it's bad news for this guy. So I did some measurements, see if that will focus, and I used two different versions of the little hat, one that has a built-in 5-volt regulator and one without. And this is the trace that we're seeing here, is the 5-volt power supply directly into the Wasatch Pixels board, and this is my rise time, and it does not boot with this slow of a rise time. I measure that. I'm going to approximately call that 13 milliseconds. If I use the 12-volt version of the hat, I have a faster rise time. I'm measuring this on the 3.3 volt rel of the ESP32, and I get a 2.5 milliseconds rise time. Still will not boot reliably. This blue trace is just a wire connection, and we can see that that has a much faster rise time, and that will boot. I'm going to use this little board that's made by Wasatch Pixels. This is called the Wasatch Duo, and it's a little hat that just directly connects on top of the ESP32. They also sell a version of this board that is intended for a 12-volt input. That's this little guy right here. I added this copper heat sink This is a linear regulator, and going from 12 volts to 5 volts is going to produce a fair amount of heat. I didn't like that amount of heat idea, so I'm going to use this little off-board switching regulator, which will run probably around 85 to 90% efficient, and I'll have this sitting by its side, and we'll end up getting a lot less heat. For this part of the video, I've disconnected the Ethernet cable because I want to connect with my phone via the access point mode. My home system is broken into two strings of LEDs. There's the first string here that I'm trying to simulate, and the second string, and both of those come over here, and that's why we have two wires into this little hat. We need to connect to the unit, so I'm going to verify that I have the correct Wi-Fi network. I do. This is WLED. I'm already there. I'm going to go into Chrome, and the IP address is 4.3.2.1. It's warning me that I don't have an internet connection, which is correct. I'm going to go to the controls, and we'll want to make sure that our two outputs are set up correctly. So my first string is starting at 0, ends at 10 LEDs. The second string starts at 10, ends at 20, and the settings will be the same between the two as far as the LED types, and the GPIO is 2 and 4. And the next thing I want to do is make sure, for just easy testing, that I'm all on one segment. So let me delete this segment. Now we're on one segment, and I'm going to make sure that the segment numbering is correct. Okay, 20 LEDs, one segment, and WLED will put the first 10 in series with the second 10 LEDs. So let's come back over to colors, and there we go. And I could double check that by doing a chase or something like that, and we'll see that all of these LEDs are all in series now.
Just finished the install of WLED and the ESP32. Here's the ESP32 board with a Wasatch Pixels Duo hat on top. You can see the yellow wires coming out for the data drive. Underneath here I have a 12 volt to 5 volt switching DC to DC converter to get the appropriate voltages to the ESP32. Purchased this off of Amazon, and here's the 12 volt input. Over here is a Ubiquiti Ethernet switch, and I have the switch in here because farther up this way I have a security camera, and so I thought I'd put everything all in one spot. This is a PoE power injector. Anyways, it turned out looking pretty slick. It works. I don't have any issues with the power up because I'm using this little adapter here. And the big reveal, this is 3.8 amps. This is just red turned on, and as I detailed earlier with the little UFO controller, I was roughly 2.4 amps. So the data stream. Here is the current with R and G turned on, 6.25 amps. And here is RGB turned on. Now that current looks a little high. I need to do a little bit more investigation, but I think with the WLED, when I say RGB only, it also mixes in a little bit of white. Here's the results. I'm not going to worry about filling out all of the columns, but so I've got, with just the red turned on, I've got 3.8 amps. I multiply that by 12 volts and then divide by 155. I get 0.29 watts. That's per LED. That's what I was getting on my lab bench with a single puck. And that agrees with the Tiva, my homegrown little microcontroller test rig. And I can come over here to the red plus green, do the same amount of math, and I get 0.48 watts, which is very similar to here and here. I believe I am finished with this project now. This is what the controller looks like. I am pretty pleased with the results so far. I saved quite a bit of cash, and I've learned quite a few things. If you have any questions, let me know. And if you want to hit that subscribe button, that also works. Thanks.